Hello everyone and welcome back to my YouTube channel. So in this video, we're going to build Captain America filter using Python and Opencv. And you also use here the Mediapipe for the hand detection. So in order to make this filter, you need to also install the library that is needed here. First one is Opencv and second one is called the Mediapipe. So in order to install this, you need to open your command prompt and type here pip install, and the library name is called Opencv Python. And also another library that's called the Mediapipe. So this Mediapipe library actually help us to detect the hand landmark, right? So I'm not going to install it here because it already installed in my system. So I'm going to click here and create here new Python file. So let's say main.py. So now what I can do, we can first create one camera, and after creating the camera, we are going to detect the hand. So in order to create the camera, we're actually using here the Opencv. So import here the CB2. Then what I can do, we can actually initialize here one video capture object. So using this, we can actually access our webcam. So let's say cb2.video capture. So inside that, we are going to pass here 0 because we are going to use our default webcam. That's been our laptop webcam. So let's say while true. Then what I can do, we can actually initialize here one boolean variable and our frame. So this is the variable for video.read because this video.read actually give us two value. One is a boolean value and second one our frame. So let's say video.read. And finally, we're going to use here cb2.imshow. So this imshow actually show the frame as the video cam. So let's give here one window name. Let's say frame. So this is the basic code when you actually create one camera using Opencv. So let's say k equal to cb2.waitKey. So don't worry, I am just going it first because this is basic one. I think you know it very well. So if k equal word q, and we are going to break the loop, right? Okay. Then finally, we are going to release the video. So let's say video.release, just here video.release. And finally, you're going to see that cb2.destroy all window. Okay. So this is the basic code for creating one camera. So I am not going to actually discuss about this thing here again and again because when I'm making the Opencv video or Opencv project, I actually already built. I just typing this code again and again. So that's why. So now let's save the code and just click on here to run this file main.py, and it will open my webcam, and you can see here, you can see my face. So now what I can do, in order to detect the hand landmark, we are going to import here the Mediapipe. So let's say import Mediapipe as np. Okay. Now we're going to create one solution for that. So in Mediapipe, there are so many things is available. So using Mediapipe, you can detect your face mesh, your holistic model, and also detect the hand landmark. So we are just going to focusing on the hand landmark. So that's why we're going to create the solution of the hands. So let's say np.solution. That's we're going to create one solution of our hands. Then what I can do, we are going to assign it inside one variable. So that's called the np hands. Okay. Then we are going to create one instance of this np hands. So let's say np hands dot hands. Okay. So inside this hands, you can assign here the max number of hand. So we have one shield. So we are focusing on the just one hand. That's the maximum number of hand should be one. It is not detecting the twice one. So that's why we are going to assign it the max number of hand. So max number of hands equal to 1. Okay. Just we're going to assign it here max number of hand. So now what I can do, we can assign into one variable that's called the hands. Okay. So hands equal to np hands dot hands, and max number of hands equal to max number of hand equal to 1. Okay. So now what I can do, we can actually draw the utils. That's mean when you're trying to draw the landmark positions, you can actually using here the np draw. Okay. Sometimes when I actually speak in English, sometimes Bangla is also coming. So that's one problem. So now let's run the code here and see that is there any error or not. If it is working fine, okay, it's working fine. That's mean we don't have any error. So now we can detect the hand landmark. Okay, cool. So so now what I can do, using this hand, we can now detect our hand landmark. So for that, we need to convert our frame into the RGB because these Mediapipe solutions take the image in RGB format, but Opencv read the image in a BGR format. So for that, we need to actually convert this frame into the RGB. So we can use here cb2.cbt color. So inside this cbt color, we can actually give here the frame. So let's say frame, and we can use cb2 dot color. So let's say color bgr to RGB, because we need to convert it here. Otherwise we got some error, because this model actually taking the input as a RGB image, that's an RGB frame, so that's why. So now we are going to assign into here one variable that's called image RGB, like that. You can also flip it, because this is this video is actually read in a flipping mode, that's like 1 meter. So you can also flip it using this cb2 dot flip. That's mean using this flip you can actually flip the frame. So let's give here the frame, and also you need to give here 1. That's been true, you are going to flip that. Let's give here the image. So this image is also the BGR. So let's assign into here the image, and you can also show it this image here. So let's say frame equal to image. So now if I save it, you can see in a flipping mode, and our image RGB also converted, right? So we don't have any error. Okay, right will be right and left will be left. So now let's go. So now what I can do, we can detect the hand, right? So for that, we can detect the landmark of our hands using these MP hands. So first we are going to process this image using our hands. So for that we actually use here hands dot process. So hands dot process. We are going to actually process it, and inside that we are going to pass our images. That's been our image RGB, this image RGB, and this hand dot process actually give here some value. So it will be result. So let's say result. And now if you're trying to actually print the result here, let's say try to print the result. So we can got here some coordinate value of our hand landmark. So let's run the code here and see that if we got here coordinate or not. Right now you can see here we don't get any coordinate, but when I up the hand, okay, I think it's better run on the terminal, right? But we also get here some Mediapipe solution, okay? So this is nothing but one class of the Mediapipe solutions. So if I'm trying to actually print the hand landmarks, that's mean if I'm trying to print the multi-hand landmarks. So let's say multi-hands, okay, landmarks, then we can actually see some values, okay? So there should be not multi-hand, okay? So let's try to print it out, and better we can run the code on the terminal, okay, because in this button it not updating the value. So some problem here when actually open the code, and it will take few seconds, but in the terminal it actually openly. So you can see a type object solution output has no attribute multi-hand. Okay, there should be multi multi multi-hand landmarks. So let's run the code here, python main.py, and it will open the webcam, I think. Yep, good. And you can see here we got some landmark of our hand. Right now you can see here we got the value as a none, but when I have the hand, you can see here we got the landmark X, Y, and Z. So this is nothing but my hand landmark positions, okay? So now we are going to iterate to all the value from here, then we can actually detect the landmark. So now what I can do, I can comment out this line, then we are going to iterate to the result value. So if there is some value, that's mean if the result value is not none, so we are going to actually take it, okay? Then we are going to iterate to all the value from this result dot multi-hand landmarks. So for iteration, we actually using here one for loop. So let's assign here one variable. So let's say hands, let's say, okay, hands LMS, let's say in result dot multi-hand landmarks. That's mean we are going to iterate to all the value from these result dot multi-hand landmarks. Then what I can do, we can actually get here two values. So one is nothing but our ID, and another one is our landmark positions. So for that we need to also enumerate it. So we can also use here one for loop. So this for loop actually give here one ID and our landmark. So if it actually give here two value, we need to also use here the enumerate. So this enumerate our this hand LMS, that's hand LMS. Then we are going to use here our landmarks. So let's say using here the landmark, okay? So now if I am trying to print here, the landmark and also the ID, that's mean the ID of our hand landmark. So what are the basically ID of that? So if I go on this hand landmark images, and you can see here there are some point. So this is nothing but the coordinate value. So there are 0 to 20, that's mean 21 value. So that's are nothing but called ID. Okay, that's been ID of all of your coordinate value. Okay, so this is the ID, and LM is nothing but our coordinate value. That's been where your hand is actually located. So we are going to actually extract the ID and the landmark of the each value. That's been each hand. Then what I can do, we can actually draw the circle like that you can see here, draw the circle like that. So now what I can do, we can print it the ID, and also let's try to print the landmark. So let's see what we actually get here. So let's save it and let's run the code from here. I think it's better run the code on the terminal so that you can see it clearly. I think you can see here it not actually give you the output, but it will give you the output in the later on. So better you can run the code in the terminal. So let's say python main.py, and you can see here, you open the webcam and you can see here my hand, and you can see here some bell is upping and down. So you can see here we have the ID. This is the 20 ID. This is the coordinate value, x coordinate, y coordinate, and the z coordinate value. So we're going to focusing on the x coordinate and the y coordinate. You can see here all the ID 1, 2, 3, 4, 5, 6, 7, and up to 20. So this is the ID. So now we are going to actually using this ID to actually draw one circle of that. So for that, what I can do, we can actually using here cb2.circle. So using cb2.circle, so you're going to give here cb2.circle. So this cb2.circle actually taking one image, and also here taking the point. So how can you got the point here? So in order to get the point, we need to actually calculate the image shape. So let's say image height, weight, and the channels. So we can get it using the image.shape. So we have the image height and the image weight and also the channel. So now we can actually get the coordinate value of the each data point. That's mean each point. Then we can actually, based on this point, we can draw one circle. So for that, we can use here LM list. That's mean this LM, not LM list. So there should be one formula to actually extract the value. So let's say lm.x. So it will actually multiply with the width of the landmark. So let's say into w, and also the y coordinate value. So y is nothing but the height. So it will be comma height. Okay. So you just change this to the y coordinate and also the height of that. So now what I can do, we can actually assign into variable. So let's call this is nothing but the coordinate of the x, and this is nothing but of the coordinate of the y. So this is nothing but our value 0.1 or 0.2. So we can actually give it inside this circle so that we can draw it. So let's say coordinate of the x, and then let's say coordinate of the y. And what I can do, we can actually give here on the radius. So let's give here 6, and let's give here on color. So let's say 255, let's say 0. And your thickness, so let's give here -1 so that it looks fill. So now if I'm save it and run the code here, or we don't need to run it here, just click on this button and run the code here, and it will open the webcam. And you can see open the webcam, and you can see here the point is actually drawn here. Okay, cool. You can see the point. So you can also draw the point. Some predefined function is the Mediapipe. So that's called np.drawingUtil. So we can also use that to draw this hand landmark. So what I can do here, we can actually using here, you can see it detect only single hand, not two hand. Okay, so you can see I actually up the two hand, but it not detected 2, 1, right? So we can also make it 2. So if I actually make it, the maximum number of hand should be 2. So it will detect the 2 number of hand, just in twice number of hand. See, it actually detect the 2 hand, right? Well, so now what I can do, we can draw one utils. So now in order to draw the hand landmarks to actually join all the coordinate value, we can use here the np solution.drawingUtils. So for that, we can use here np dot, that's mean np dot solutions, the solution. From the solution, we actually using here the drawing utils, so that we can actually connect all the points. So let's assign into one variable that's called np draw. Okay. So now we are going to use it, instead of using this circle, we actually use here this np draw. So let's use this np draw. So there should one function that's called the draw landmarks. So landmarks, and inside that we need to give here our image and also our hands LMS value. That's been our LM list, and we are going to actually draw the hand connections. So that's why you're going to use here the np this np hands. not MP draw, MP hands, and you're going to connect all the hand connections. So let's say hand, and you're going to say that hand connections. Okay. So now, well, so let's run the code here on the terminal. So let's say Python. So there should be small Python main.py. Well, and it will open the webcam just soon. Okay, and you can see actually draw the hand landmark. Okay, it's also detect the two hand. So we need to actually make it single one because Captain America had only one shield. So it can also detect only one hand. That's one thing. So now what I can do, we can actually add here the Captain America shield. So for that, we need to actually calculate the center of our hands. Okay. So we can make it 1 right now. That's when we are going to max our hand should be 1. So for the Captain America sheet, we actually using this picture america.png, this shield. Make sure that your image should be transparent. So now what I can do, we can going to actually load the images. So we are going to use here cv2.imread. And inside that, we are going to actually give here our image path. So let's say america.png. And also we need to give here -1 because this is one transparent image. So let's assign into the variable that's called sheet. Okay. So now let's run the code and understand the logic, how can actually build the applications. So it will open the webcam here right now, and you can see detect my hand landmarks. So what are the actual plan of attack that you're going to do? So if this hand is closed, we are not going to show the shield. But when the hand is opened, we are going to actually show the sheet. Okay, and it is detect only single hand, not double hand. Okay, so when it is closed, we are not going to show the sheet. If it is up, that's been open, we are going to make this hand should be one Captain America shield. You can see that Captain America shield as a Ubala transparent, right? So now what I can do, we need to actually calculate the distance of all the coordinate. So if I see the images, so we are need to actually first detect the distance of the east, that's been this point to this point, and also you need to calculate the ratio of the hand. Based on the ratio, we're going to see that our hand is open or not. So first, we need to actually calculate this palm distance. Then you're going to actually calculate this whole distance, and then you can divide this distance by the palm. Then you can get the ratio. So how can you actually calculate the distance of the each point? If you know math well, so there should be one rules to actually calculate the distance. So that's called the x2 minus x1 whole square plus y2 minus y1 whole square root over, right? So we are going to focusing on this tip of the value 4, 8, 12, 16, and the 20. So if it is open, then you're going to see that we need to show the shield. But if it is closed, so you're going to see that we don't need to actually show the sheet of the Captain America. So for that, you need to also initialize our this tip value. So now what I can do, we are going to define here one functions. So this is the function, and this function is called the position data. So it will take the data of the wrist, that's mean this wrist, and it will take the value of the thumb tip. We don't need the thumb tip right now. We need the number 8, that's been called index finger tip. We need the 12. This 12 is called the middle finger tip, and 16 is called the ring finger tip, and 20 is called the pinky tip, right? So we need the wrist, we need the index MCP, we need the index tip, and middle tip, and the pinky tip. Just we need this 0, 5, 8, 9, 20. Okay, 0, that's means 0, 5, 9, 8, and the 20. So now we need to calculate the distance of our hand. That's we need to calculate the ratio of our hand. So in order to actually calculate the ratio of the hands, we need to focusing on this picture. So using this picture, first what I can do, we can calculate the distance of each point and also the distance of the palm. Okay, then when I divide this distance by the palm, we can get the ratio of the hand. So now we're going to focusing on the 4 value of the position data. 1 is a 0. 0 is nothing but our wrist. And 5, that 5 is nothing but called the index finger MCP. That's been this one. And index finger tip, you also need it. Number 8 and number 9 and number 16 and the number 20. So this is nothing but to calculate the distance of the each data point. Okay, and also this is the value for actually calculate the plumb. Okay, so let's define here one function so that you can actually understand it easily. So this is one function which will taking one lm list. So lm list is nothing but our coordinate value of the each data point, and we need the width, index MCP, index tip, middle MCP, and the pinky tip. So width is nothing but this point, so this 0. Then we have the index MCP. So index MCP mean this is the nothing but called the 5th number, and we have the 8 and 9 and 20. Okay, 8, this 8, 9, and the 20. Okay, so 8 to 20 we're going to calculate the distance, and 8 and 9 we need it because to actually calculate the plumb distance. Okay, calculate the plumb distance. So when I divide this distance to the plumb distance, we get the ratio. Okay, so now what I can do here, we are going to define here one function that's called the calculate the distance. So let's say def calculate. Okay, so let's say calculate distance. So the distance is actually taking the point number 1 and the point number 2. So let's say point number 1 and the point number 2. So let's make it right now pass. Okay, now we need to actually assign here this lm list also. So for that we are going to actually create here one empty lm list. Then you're going to append here the value of the coordinate of the x and also the coordinate of the y value. So what I can do here, we are going to see that lm list dot append. We are going to append here our coordinate of the x and the coordinate of the y value. So let's say give here coordinate of the x and the coordinate of the y value. So now we're going to pass this lm list inside our position data. So let's also pass it out. So let's pass it now. So let's call here the position data. So let's say position data, and you're going to pass here the lm list. Okay, so now let's save it and also try to run the code if there any error or not. Okay, so we don't have any error right now. That's when our code is working fine here. So if I actually close it, and you can see here no error, that's when this function is working fine. So now we are going to pass this value inside our calculate distance. So we're going to calculate the distance from the which to which. We are going to calculate the distance from the first which to the index MCP. That's in this position, this 0th value to the index MCP. Index MCP means this one called the 5. That's going to calculate the distance from the 0 to 5 because they have one connections. So for that we are going to use here this function that's called calculate distance. So this calculate distance actually taking the point number 1, the point number 2 value. So now we need to actually start here the x1 and the x2 and also y1 and also y2. So for that we are going to actually using here 4 variable x1 y1 and also call the x2 y2, and we get the value from our point. So point 1 give here the x1 and the yn value. So this should be the position number 0 and the position number 1. So P1 and the position number 1, and this x2 and the y2 values come from the point number 2. So let's say PT and just give here 0, and PT let's give here 1. So we got the x1 and the x2, x1, y1, x2 and the y2 value. So now we can actually calculate the distance of the each data point. So let's say we are actually using here the formula of that. So let's say x2 minus x1 whole square. So for whole square we can actually using here double multiple sign and 2. Then you're going to use here plus sign, x2 minus x1 whole square and y2 minus y1 whole square. So again we can use here the 2, and we can use here one single bracket here. Then we're going to divide this by 0.5. That's been our root. So for the root you can actually divide 1.02 by 2. Okay, let's say by 2. Okay, so this is the root, right? So we can actually use here the again the 2 multiple sign. Now you're going to assign into one variable that's called the length. Okay, then you're going to return it as a function value. Okay, so let's actually return here the length of that. So now if I save it and also try to calculate the distance of that, so the first value is come from the width to the index MCP. So it will actually give here the distance of the whole data point of the plum. So you're going to assign into the variable that's called the plum. Okay, and you're going to call the function that's called the calculate distance, and this calculate distance is actually taking the value as the width, that's mean this width value, and also the index MCP. So let's assign into here, so width and the index MCP. So you can see here we give here some value of this LM list 50, and what is this actually? So this width is nothing but the position of the 0, so that's why 0 to 0, and you can see here 0 to 0 and 0 to 1. So this index MCP is nothing but the value of the 5. You can see here this is the value of the 5. So 5 to 0 and 5 to 1. So like that. So this should be the 9 to 0 and 9 to 1, 20 to 0 and the 20 to 1, like that. And you need to also assign into in a global variable so that you can access it from the anywhere in your Python script. So now we can calculate the distance of that. So you're going to assign into one variable that's called the distance. Okay. So distance from the each data point, just to calculate the plum here right now. So now I'm going to calculate the distance of the 8 to 20. Okay, 8 to 20. So 8 number is nothing but called the index fingertip, and 20 is called the pinky tip. Okay. So now you're going to use here the calculate distance, and we are going to just pass it here the number 8. So number 8 is nothing but our index tip, and the number 20 is called the pinky tip. Okay. So let's say pinky tip, this one, pinky tip. Okay. Let's assign it here. So now if I'm trying to divide this plum by ratio, not distance by plum, we actually get here one ratio. So let's say distance by plum. Okay. Now we can actually get here one ratio. So this is nothing but ratio of your hand. So if I'm trying to print it, so let's try to print here the ratio of the hand. So now if I'm trying to go on the terminal, and let's say type here python main.py, and you can see here we got some value. So I actually make it open, and you can see here 2.5 or something. If I actually close it, and you can see here the value is decreases. So you can say that if the value is greater than 1.5 or something like that, so you can actually show the sheet. Okay, show the sheet of that. And otherwise we don't going to show the sheet, right? You can see here 0. 0 means our hand is nothing but closed, but when actually make it cool, that's been open, it will be the greater than should be 1.5, like that. Okay. So now what I can do, we are going to actually use here one condition for that. So if the ratio is, let's say if the ratio is greater than 1.5, okay, then we can say that our hand is open. So if our hand is open, we can actually show the sheet. So let's say hand open. Let's test it out. Hand open. Now let's actually run the code here. Let's go on the terminal, and you can use this terminal here. No need to create the new one. Okay, and you can see here you can see right now you can see here right now hand is closed, but when up you can see your hand is open. So now right now hand is open. Now we can actually overlay the image of that of the sheet. So for that, what I can do, we need to define here another function that's called the overlay transparent, and also you need to calculate the center of our hands and also calculate the diameter. So if the diameter is 0, then you're going to actually show the sheet of the Captain America. So now what I can do, we are going to access the middle point of our hand landmark. So for that, we actually using here this middle MCP. So now we are going to actually calculate the center of the X and also the center of the Y using here this middle MCP. So let's say middle MCP, and the first position value is nothing but our center of the X, because if you see this LM list, so this is the coordinate of the X and this is nothing but the coordinate of the Y. So this is the coordinate of the X value. So middle MCP 0, that's mean it actually give here the center X value. So let's say center X, and another value is called the center Y. So it will definitely actually give here the value as 1, position number 1. So let's give here position number 1. So we're going to calculate here the center number Y. Okay. Then what I can do, we are going to actually give here the size of our sheet. That's mean this sheet, okay, that we actually already loaded. So let's give here one sheet size of our images. So let's say give here shield size. So let's give here the sheet size, let's say 3.0, okay, size of the sheet. Then we are going to actually calculate the top left corner, and also you need to actually calculate the diameter of that. So let's actually also calculate the diameter first. Then you're going to calculate the top left corner of our images, okay. So let's say diameter. So you can get the diameter when you actually cross this palm. It's not plum like that, PALM. So you can cross this plum to the value of the sheet size. Then you can actually get the diameter of the your picture. So let's cross it right now. Cross, and you can use here this sheet size. So better you can take the value as the round format. So let's say using these round functions, okay. So now we can get the diameter, okay. So after getting the diameter value, we are going to calculate the top left corner of our hand, so that it not actually go out of our hand. This means our sheet should be looked in a hand, okay. Let's actually run the code, then you can understand it easily what I'm actually talking about here. So let's say it will eat my hands. So if my hand is open, so this image should be overlay on this picture of the hand, not like that, not this portion, this point or this point or this point like that. Just you need to show it based on this middle point. You need to show it the whole hands, right? Okay. And based on the hand, it will actually increase or decrease the size of the your sheet. If it actually go far, your sheet should be the small based on the size. If it will come closer, your sheet should be look bigger, okay. So that's how you calculate the diameter of that. So now what I can do here, we are going to actually using this diameter to calculate the sheet size, ratio of the sheet size. So now what I can do, we are going to calculate also the top left corner of the images, so that we can actually set the sheet inside our head, inside our hand, okay. So for that, we are going to actually minus the diameter divided by 2 from the center of the x. So let's say center of the x minus diameter divided by 2. So let's say diameter divided by 2. So this diameter divided by 2. Then we get the value of the top left corner, okay. So it will, the top left corner value is nothing but called x1. So let's say x1, okay. There should be, why I am actually opening the caps lock, x1. And also we get the value of the y2 also, okay, not y2, actually y1, okay. So you can actually using here same round function to make it simple. So let's use here the round functions, okay, these round functions, and let's actually close this bracket. So let's use this round function again here, round, and just close it. So now we calculate the top left corner of our images of the sheet. So now we're going to actually give here some condition. If diameter is 0, we can actually overlay the shape. Let's overlay the images. Otherwise, we are not going to actually overlay the images, right? So now what I can do, we need to also calculate the image height, weight, and the channel. So we are going to use here image dot shape, and this value actually give us actually 3 value: height, weight, and the channels. That's when your image is RGB or a grayscale image. Then you're going to actually give here one conditions. So if the x is actually less than this, f is 1 is less than 0, then you're going to set it to be 0. And if x1 is greater than equal to width, that's mean width of the images, you're going to make it should be width. Okay, let's actually format it out right now. And also the diameter. So this is the condition of that. So using the condition, we are going to actually calculate the diameter of that. So if the diameter is not equal to 0, that's mean our hand is right now open, okay. Hand is right now closed. We don't need to overlay the images. But when this hand is open and you get some diameter value, and based on the diameter value, you're going to actually overlay the picture. So this is the condition of that. So you can see if it is, it actually follows this condition, we are going to assign it to 0. Okay, this 0. If it is less than 0, that's when you're going to assign it to 0. If it is greater than w, we are going to assign it to w, and also for the x, y1, just assign it to 0 and assign it to height. Then you're going to actually take here one condition, x1, that means this x1 plus diameter, the actual diameter, if it is actually greater than w, then you're going to minus it from the x1, and another one for h minus y1, same as it is, and we're going to actually assign this value inside our sheet size. So now if the diameter is not equal to 0, so let's say if diameter is not equal to 0, that means it have some value. Then if it is not 0, so you're going to actually overlay our images of the sheet. So for that, we're going to assign here, we are going to define here one functions, or you can say method here, that's called the overlay transparent images. So which one taking one images as a background and also our actual images, that's been our actual frame. So now let's define here one function that's called the overlay transparent. So which one take one image, this was called the background image. So this background image is nothing but our this frame, and another one is called the image to overlay, that's our sheet, and the x1 and the y1, this is the coordinate of the x1 and the y1, and the overlay size. So by default is none, we actually give here the sheet size should be 3. Okay, so what actually happening inside this code, so this line is actually taking one copy of our background images, and this is the code for resizing our frame, that's been our ROI based on this overlay size. We are going to actually resize this based on our sheet images. Okay, so then we are going to actually extract, or you can say cut the alpha channel of the RGB images. If you see this america.png, this file, and you can see here it have one alpha channel. So you need to actually remove this alpha channel from these images. So for that, we are going to actually using here cb2.split. cb2.split, you actually pass here the image to overlay. So it actually give here 3 value BGRA. So why BGR? Because this is Opencv, and Opencv read the image in a BGR format, so that's why BGRA. So then you're going to actually drop this alpha channel from here. That's mean we are going to actually extract the alpha marks of the RGB image and convert it into the RGB. Okay, so now we are going to merge this BGR. We don't have any alpha channel right now. Then you're going to actually use here on median blur to actually remove the noise. You can actually use here the Gaussian blur also. Then what I can do, we are going to calculate the shape of our overlay color images. That's been our RGB image, or you can say the BGR images. So from the background account, we are going to cut these images based on our hand landmark positions. Then what I can do in this line, we actually black out the area behind the logo. Okay, this is nothing but called the image1bg. So if you see this america.png, you can see here one black pixel. We are going to just remove this black pixel from the images. So that's called image1bg, and this is the code for the foreground image fg, that's been the foreground. So it actually mark out the logo from the original images, that's been on this america.png. It actually first remove this black point, then this is actually extract this whole images, that's been this sheet only. Then what I can do, we are going to actually set these images, this image bg, that's been our background and also the foreground. We are going to add it, and we're going to actually put it inside our RU, that's mean ROI, region of interest, inside our background images. That's mean if our hand is detected like that, just it will cut it one ROI, and based on this ROI, it just going to show the sheet, right? So now what I can do, we can actually call this function that's called the overlay transparent. So you don't need to worry about the code. You actually get this code in a GitHub link, and there should be also one password, and password is captain, just captain. Okay. And if diameter is 0, we are going to actually call the function here. So let's say overlay transparent, and this transparent first take one background image. So that's called background image is nothing but our images, and another one is images for called the sheet. That's been our sheet images, and it will get taking the coordinate value x1 and y1, and also the size of that. So our size is nothing but our shield size. That's been this shield size. Okay. Now let's assign it to the variable that's called the image. That's been this image. Okay, so our code is right now ready. So now it's time to actually test it out that our code is working here fine or not. So just go in the terminal and type here the python main.py. So let's say python main.py, and I'll run the application here. Okay, so see how I actually overlay this, we got some error. So function object has no attribute copy. So I think we got some error here and do some mistake here. Okay, we do the mistake of here, this called shield. We actually do the spelling mistake here. So this should be the shield. So now if I'm trying to run the code here in the terminal, let's say python main.py. Okay, then I think hopefully it will work correctly. Okay, you can see here it will actually show, but it not actually change the distance of that. So why actually got this error? So let's check this out. So basically we got this error because of we have one simple bracket mistake, because we need to divide these by 2, that's mean root square. So that's why it's not actually give here the value of the coordinate correctly. So now if I'm trying to actually also try to print this ratio and also see it, and try to open the terminal here, and let's say type here python main.py. And now if I'm trying to run the code here and see the output, then you can see it working here fine. You can see it actually show it, but you can see here the value is nothing but very less. You can see here, and off value is nothing but 1.5, something like that. So because of the rows of the conditions, so that's why we got here 2 value, that's been 2 point off. So you give here the condition as if it is up to 1.5. So we're going to show that it is open and this is closed. So let's make it 1.2 right now and run the code here again. Then you can see here the sheet is actually show based on your hand landmark. You can see a sheet is right now showing, and you can see also the hand landmark positions. Just for one bracket, we actually got this kind of error. So you can make it 2 hand. It's up to you. You can see here right now. You can see a sheet is actually coming up. Cool. Open and sheet is okay. You can also increase the size of that. So let's try to increase it. Okay. So for though that we can use here this video.set. So let's say video.set, and inside this we give here 3, and you need to give here the width. So let's give here 12, or let's say 1000, and let's say, why I am doing mistake again and again. So let's say video.set for number 4, and let's give here the 720. So let's give here 720 and run the code on this button. Okay, so now you can see here our sheet is actually, our frame is right now big based on these conditions. So now you can see here our Captain America shield. Based on that, it also resize the size of that. You can see here how cool is it. So this is all about the whole tutorial. So make sure to subscribe to my YouTube channel, and I'll be back with another tutorial. So till then, take care and bye bye.